Hello friends, welcome to my channel. So we will start with DBMS and RPSC Programmer. So what is DBMS? A DBMS is a software system used to store, retrieve and manipulate data. Before we create a database, we design ER diagram for the database. ER diagram is a diagram that represents relationship among entities in a database. So it basically expresses the logical structure of a database. It is the visual representation used to design database and helps in understanding connections between different elements in a database schema. So ER diagrams are used to model real-world objects like a person, a car, or a company. ER diagrams require no technical knowledge and no hardware support. So why ER diagrams are so important? ER diagram acts as a blueprint for designing database. They show what kind of information will be stored in the database, how different pieces of information are related to each other, and what rules should be followed when adding or changing data. It reduces the complexity and allows database designer to build database quickly. Suppose you are planning a big puzzle. The ER diagram is like a drawing a picture of all the pieces and how they fit together. Before you start putting it together, it helps you understand what pieces you need, how they connect, and where they belong. This way, you can build the puzzle more efficiently and make sure everything works smoothly. There are various symbols in ER diagram rectangles. This symbol represents the entity type. Example is student. Ellipse. This symbol represents the attributes of the entities. Diamond. This represents the relationship between entities. Lines. It links attributes to the entities and entities to the relationship types. Double rectangles. Double rectangles are used to represent the weak entity. And the last one is double ellipse. Double ellipses are used to represent multi-valued attributes. Components of ER diagram. The first one is entities. Entity is basically a real-world object or concept that can be uniquely identified and about which data is stored in the database. For example, in a university database, entities could be student, instructor, or the course. Entity is represented by the rectangle symbol. Weak entity. A weak entity is an entity that cannot be uniquely identified by its attribute alone. It depends on the existence of the another entity called the identifying or the owner entity. For example, the order item entity is entirely dependent on the order entity, since we can't have an order item without a order entity. Weak entity is represented by the double rectangle in an ER diagram. Now next one is attribute. Attributes are properties or the characteristic of the entities. For example, a student can have the attribute name or student ID or date of birth. Attributes are represented by the oval symbols. Now we have multiple type of attributes. First one is key attribute. A key attribute is an attribute that uniquely identifies an entity within an entity set. We use key attribute to identify any single line of data from the database. To identify which attribute to be the key attribute, first check it shouldn't have same value for the multiple records or instances. Key attribute is also divided into two parts: primary key attribute, composite key attribute. A primary key is a key attribute that uniquely identifies each entity in an entity set. It must have a unique value for each entity and can't be null, since we are using it to identify a record in the database. For example, consider an entity set for a student with the attribute student ID and name. So here we are using student ID to be the primary key attribute to identify the student record. Composite key attribute. A composite key is a key that consists of more than one attribute. Together, these attributes uniquely identify an entity. For example, consider an entity set student with attribute student ID and name. If we need to use both the student ID and name together to identify a student, then this forms the composite key. Composite attribute. An attribute that can be further divided into smaller subparts represented by the ovals within the attribute oval. For example, an address attribute might be composed of street, city, and zip code. Another example might be the name, which is composed of the first name, middle name, and the last name. Now, the third one is multi-valued attributes, an attribute that can hold multiple values for a single entity, represented by the double oval symbol. So here a student can have multiple phone numbers. Derived attributes, an attribute whose value can be derived from the other attributes, represented by the dash oval. For example, we can use the date of birth to identify the as attribute. Now the next topic is relationship. Relationship represent how entities are related to each other. They describe the association and interaction between entities. For example, a relationship between a student and course might be a enrolls in as a student enrolled in the course. Relationships are represented by the diamond shape connecting two or more entities in a ER diagram. Here is the ER diagram of the previous example. Here student enrolls in the course. So this enroll in represent the relationship between the entities student and the course. There are many types of relationship. First one is one-to-one relationship. In one-to-one relationship, a single instance of an entity is associated with only one instance of another entity and vice versa. For example, a student has only one identification card, and a single identification card can only be issued for a single student. The second one is one-to-many relationship. In one-to-many relationship, an entity in the relationship can be associated with multiple instances of the another entity. For example, a customer can place multiple orders, but an order ID can only be associated with one customer. Now the third one is many-to-many relationship. In many-to-many relationship, multiple instances of each entity can be associated with multiple instances of the other entity. For example, a student might enroll in multiple courses. Likewise, a course can have multiple students. So this is all for the ER diagram. If you like the video, please like and subscribe to my channel. Thank you.